Trigonometry is the study of the mathematical relationships that exist in triangles. These relationships are in the form of ratios using sides and angles. In here, only an introduction to trigonometry will be presented and will involve right triangles only. First, let's begin by saying that right triangles have very predictable and useful ratios, because if we change the measurement of one angle or side, the other angle or side will also change accordingly. For example, if I take a 45-45 right triangle and increase one of the acute angles to 50 degrees, then the other acute angle must decrease to 40 degrees. Therefore, following this line of reasoning, if the triangle remains a right triangle, then when an acute angle is 5, the other acute angle must be 85. Notice how this angle at 15 makes the other one drop to 75. And this angle continues to drop in measure as this one is increasing, and so on. This angle changing variation is what is behind the calculations of trigonometric ratios. Because a right triangle has 3 sides, then there are 3 basic trigonometric ratios to study. There are more ratios, but because this is an introduction, we will only study 3. The 3 ratios for each angle are the sine ratio, the cosine ratio, and the tangent ratio. In trigonometry, we only compute the ratios for the angles that change. This means that the 90-degree angle of the right triangle will have no ratios. Okay, the sine ratio for any angle is always calculated by the use of the opposite side of an angle divided by the hypotenuse. And the cosine of any angle is calculated by the use of the adjacent side of the angle over the hypotenuse. The third ratio, the tangent, is calculated using the ratio of the opposite side over the adjacent side. Let's review it. For any angle, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Because we're using 2 angles only, notice that when we compute the sine of an angle, we are actually using the same numbers as for the cosine of the other angle, the complementary angle. For example, the sine of angle 30 is identical to the cosine of 60, and the cosine of 30 is identical to the sine of 60. Why? Because we are using the same numbers to calculate the ratios. In this example, for instance, the sine of 30 is 3, the opposite side, over 6, the hypotenuse, or 1/2, or 0.5. And the cosine of 60, the complement of 30, is the 3 again, but this time as the adjacent side for the 60-degree angle, over 6 for the hypotenuse. Now, in calculating the tangent of an angle, we do not use the hypotenuse because to find the tangent, you need the opposite side of the angle over the adjacent side of the angle. So the tangent of 30 degrees is 3 over 3 the square root of 3. Canceling the 3's, it becomes then 1 over the square root of 3, or 0.5774. And in the tangent of 60 degrees, we flip the numbers to make it the reciprocal of the tangent of 30 degrees, or 3 the square root of 3 over 3. Again, canceling the 3's, it becomes the square root of 3, which is 1.7321.